The world's oceans, ancient and rife with biological and chemical diversity, contain important photosynthetic marine bacteria. In fact, the first bacteria identified to produce oxygen is cyanobacteria. Cyanobacteria is a gram-negative prokaryote that in recent years has shown promising effects in the development of anti-cancer drugs, potentially serving as the gateway towards more cost-effective treatment and preventing unwanted side effects. Cyanobacteria is an essential part of Earth's ecosystem, synthesizing a variety of bioactive compounds. Broadly, bioactive compounds are chemical compounds that possess a biological effect on living organisms which can be extracted from cyanobacteria and destroy cancer cells via apoptosis, the underlying mechanism of action here being the destruction of unwanted cells by proteins called caspases, which can be activated from an intrinsic or extrinsic pathway and thus break down cellular materials. Among the biologically active compounds that can be extracted for this purpose is the compound gator-bulin-1. Cancer is an umbrella term for disorders of which there is a malignant growth due to uncontrollable cell division. So GB1 targets tubulin, a required protein in cell division that facilitates the polymerization of microtubules that provides the cell with structural support. Pre-existing chemotherapy drugs also target tubulin, but GB1 interacts with tubulin in a new way. Additional trials are required before GB1 can be replicated and officially used in the development of pharmaceuticals, but it shows promise. Because cyanobacteria is useful in the destruction of cancer cells, and it is very easy to access and replicate in labs, it can serve a great potential in the development of new pharmaceuticals because it can destroy cancer cells, and there is also the added element of the compound GB1 that targets tubulin. Therefore, it can increase the efficacy of drugs that focus on cancer-resistant cells, and additionally provide an alternative that is easier to access and develop.